Welcome. So here we are on day 3 of our project. We're going to look at how to put spirals now into our greeting card app. I'm also going to talk about the Bezier and quadratic curves, although we're not going to use those. Those are kind of plain and not really interesting, but we will do some things that are more interesting with them. So today we're going to add spirals and a figure I call a cobweb to our code. So let's start by going over some of the background here for these things. So we're going to talk about spirals, the quadratic and Bezier curves, and the cobwebs. So you'll recall that last time we did the polygon, and we did the polygon by rotating around a center point, and we used our cosine and sine trigonometric functions to calculate the x and y values for the vertices, that is the points of the polygon. And remember, those points are on a circle with a fixed radius. So basically the circle inscribes the polygon. That's actually kind of part of the definition of a polygon, that all the angles are the same, and so it will fit into an inscribed circle. So if we do the same process, but we increase the radius as we go around and we rotate around many more times, we're going to get a spiral. Now, one thing that was interesting for me in doing this is I made the spiral better when I set up to teach it to you. So originally I had the spiral set to grow a fixed factor, and I realized I could get more interesting spirals by adding a bit more randomness. So here's our spiral code. It's not really hard at all, and especially if you understood how the polygon code worked. Now I have a couple of things here that I just did because of the slide. So I wanted to try to fit everything on one slide. So you notice up here I'm declaring an angle variable, setting it to 0, and declaring a px and a py variable, and I'm not setting those. And I'm doing all that on one line. You're allowed to do this, but it makes the code hard to read. So I usually avoid doing that. I won't do that in the code, but I did it here on the slide so we could get the stuff that we needed to see all on one slide. The next one is the radius. Originally, this was generated in the outside code, and that's just a common variable that I use for a number of figures. But again, as I started to look at this, I realized that if I kind of tightened the radius up and made it a bit smaller, I'd get better spirals. So what this does is it takes the maximum figure height, and that's a parameter that the user can set on the interface. And all these variables that are parameters, I have a P like that there just so it's easy for me to remember. So on the interface, there's the max figure height and max figure width. And so this is going to take the height, multiply it by the math.random, which of course is going to be from 0 to just less than 1. And then it'll divide that result by 4. And the way the order of operations go here is that it'll do this first and then divide it by 4. Okay, so this could be 0 divided by 4, or it could be real close to whatever the figure height is. Then that's divided by 4. And then we take the floor of that, which throws away the fractional parts, so we end up with an integer. And then we add 5 to that. So it should be a tighter spiral. And I've tested it, and it works pretty well. The radial growth factor, originally it was a constant, and I had just set it to 0.75 through observation and running this many times. But it's actually a lot cooler now that we use a random instead. So again, math.random is going to give me a value from 0 to just less than 1, and that'll be a decimal value. And then I'm actually adding 0.25 to that. So if the random is 0, the smallest value here will be 0.25, which is, a third of what I used to have. And the largest value would be just less than 1.25, which is, 2/3 more than what I had. So then if we look at the loop, here's the loop. And now one thing I wanted to point out to you here, Remember before when we were talking about the radians, I said don't worry about translating radians to degrees. So I know that math.pi times 2 pi radians, is a complete circle. And so basically, I'm going to draw my spirals by drawing a series of segments where I've divided the circle up into 50 sections, and I'll draw 50 little small lines. So it's not really a true spiral in the sense that it's a series of straight lines that join the points along the spiral. But by observation, I found that 50 is a good value, and I really can't tell that it's actually composed of these little segments. It looks like a pretty smooth spiral curve. So recall before in our polygon code that we took this angle and increased it by 1 each time. So the angle was actually the segment of the polygon. So for instance, if we were doing a 6-sided polygon, the angle would be 1/6 of math.pi. And so you notice here that angle is increasing. So this says angle is equal to angle plus 50th of a circle. Okay, so every time we go through here. Now, number of rotations is very large, and that's actually going to have it go around. So one rotation is 50 iterations. And then, of course, we want to do that many times because now we're not going around one time. We're going around a bunch of times to make the spiral. So as we go, the x and the y is the center point. We calculate new points, px, py, and we draw a line to them. And then once we got the whole thing done, we stroke to actually render it. One thing that's a little strange here, and it bothered me at first, and I decided just to leave it go, is it doesn't really specify where the first point is. And so what happens is the first time into the loop, it says it generates px and py, and it tries to draw a line from no existing point to them. That seems to just fail without any kind of error. And then the second time through, it's now at px, py, and then it begins to draw from there. I played around a little bit to try to give it an initial starting point, and it didn't seem to work very well. And so I just decided to leave it that way. So it's kind of an interesting thing. Now, what's not shown here is this code is framed by a begin path. And I think the begin path then is what establishes that there's no previous position. So you might have noticed here that a lot of the canvas functions have what's called a context point. And so when you draw from the existing point you're at, that's the context point, to some other point that you specify. Okay, and you might have got that from the supplemental videos, especially things like arc2 and line 2. So line 2 doesn't make any sense unless you know that you're already on a line and you're going to a new one from there. And that's what is a little weird about this. The first time through, we don't have that existing line. Then after that, the new endpoint becomes the previous line, and we keep going from there. Okay? So hopefully that's sort of clear about how the spiral works. Let's go ahead and add the code to our app. And let me go ahead and end this, and we'll come back and pick it back up. And I'm going to go on into NetBeans. And I probably shouldn't have done this, but I already have the code loaded. So basically, whoops, that looks like it's the wrong code actually. Let me take a quick look here. So we'll go to the script. Yeah, so it's right. I can tell because those are the figures here. It's saying day 1. It should say day 3. So this is day 3, and what I want to do is I want to start by taking my code from day 2 and adding it to the day, make a new folder, day 3, and then copy it into the day 3 folder. If my code was a little screwed up or had some problems or it wasn't here, I can go ahead and get the new code that's the starting code for day 3, which is really what I'm using here. Okay, let's go right into our index.html. we'll come on down here, and you can see in our figure selector we have the checklist, the checkbox for the line, the rectangle, the circle, and the polygon. And we're going to go ahead and add that for the spiral. And again, the easiest way to do that is just to go ahead and copy these two lines, hit enter to put a blank space in there, and then Control V to paste them in, and then just edit them. So instead of polycheck, this ID is now going to be spiral check. So I'll change that in both places. And again, the way this works is the ID for the checkbox is spiral text check, and then the label is for that. So the label is basically goes with the next figure that it follows. So whoops. So we'll put this in spirals. I guess we can say spirals. And so then we have spiral check. We'll save that. And now we're going to go on over to our JavaScript, and we'll start by adding the spiral here, var, and let me check and make sure. I'm going to skip two of the figures that I had in the original code. Sure enough, they are going to be skipped here. So I'm going to go ahead and add, let's see, make this 6, and the reason for that is I had two other figures, the Bezier and the quadratic curve, and I'll talk about those today, but we're not going to include those in our project this week. At the end of the week, I'll give you the code for those. The reason I'm not doing that is they're just not that interesting. I don't like what they generate. It looks like just some random scribbling. It doesn't look pretty or anything. Now, I'll use the Bezier curve in a moment, or excuse me, the quadratic curve in a moment when we do the cobweb. And when we do tomorrow, we'll do the swirl. We'll use the Bezier curve there. So those are more interesting than just the random results that I got with those. Okay, so I've scooched down now to my switch statement here. And again, I'm going to add a switch case, that is, case spiral. And then this is going to be the code that generates the spiral. And I'll go ahead and put the break in there. I like to do that when I create a block. I put the end in immediately, and then I don't run into trouble and forget about that. Okay, so this is going to be, hey, you know what's funny? I changed the code and I don't have a printout of it. I might have to go back into my PowerPoint and copy the code. So let me pop over there real quickly. Let's see. And we'll just go ahead and grab the code. And we'll see if it copies from PowerPoint. Sometimes when you copy code from PowerPoint, it screws it up because Microsoft uses non-standard encodings for some of the things. So I'll paste this into the editor, and we'll start fixing stuff here. And then I'm going to go through real slowly so you get a chance to type this in, okay? So we're going to set our angle to 0. So that's a variable called angle. We'll set that to 0. Then we're going to type in a variable px and py, and notice the comma separates them, and those aren't initialized because we're going to initialize those in a minute. Radius is already declared, so we don't use the var keyword to declare it again, but we're going to reset it. So this is going to be radius equals math.floor, then in parentheses, math.random, open close parentheses, times P max fig height, and that's in camel case. So M, F, and H are all capitalized. And we're going to divide that max figure height by 4. Then we have a closed paren that matches the floor. So that's going to basically give us a random number times figure height, which is going to go from 0 to just less than figure height. And we're going to divide that by 4. And then to make sure we have something, because it might zero out, we'll add 5. And the floor removes the fractional part before we add the 5. Okay? All right, then we're going to do our radial growth factor. And so I'll have a new variable for that. So I'm just going to call it radial growth factor. Notice I always use the camel case when I have variable names that have multiple words. So we make the first character lowercase, and then each additional word is just capitalized. So radial growth factor, we have G and F. That's going to be math.random times 0.25. And that's kind of interesting because I guess theoretically that could be 0. No, it can't be. So I'm not multiplying it. So if it zeroes out, its lowest value will be 0.25. Its highest value will be close to 1.25, a little less. Originally, this was a fixed constant at 0.75. That makes the spirals a lot more interesting. Okay. Now we're going to have a for loop here. So we're going to type this in, and that's going to be for, and then we start with a parens, var n equals 0, semicolon, space, while n is less than 50, space, times, space, number of rotations. And again, this is a constant, so the r is, a variable I've already declared, and we use the camel case. It's really important that you spell everything correctly because this is defined up in the top of this method later on, previously, I'm sorry. Then we have a semicolon, and then we have n++. While I'm here and you're typing, I'll just talk about what this means. So this is a loop that says I'm going to have a variable called n, which we call a loop counter. I'm going to start it at 0. The loop is going to run as long as it's less than 50 times the number of rotations. Remember, we do 50 rotations for 50 parts of the circle as we go around for 2 pi radians. So this could be a pretty large number. If I have 8 or 10 rotations, it would be 500, right? So 400 to 500 there for 10 rotations. I'm sorry, 100 rotations would be 5,000, sorry. And then what this n++ does is it adds 1 to n each time. So the loop will keep going. The first time it'll 0, then 1, then 2, then 3, etc. And each time it'll check against this value to see if it's gotten larger. And when it finally has, it's no longer true. It'll be equal because it won't be less than, then the loop will halt. Okay, inside the loop, I'm going to take my radius, which I randomized, and I'll add the radial growth factor to it. So this says take what's already in radius, add the radial growth factor to that, and reassign it. So that changes radius. That's a kind of assignment when we set a new value for something. And this is a kind of an assignment that's based on what's already in there. So this says basically add the radial growth factor to what's already in radius to get a new value for radius. Same thing here with angle. And notice when I'm adding, this is 1/50th of a circle in radians. So each time through I add 50 and it'll keep going around. Here's where I go ahead and calculate my x and y. And notice that that's in relation to my center point. So x and y is my center point. The new values px and py are ranged away from the center point. So we take the radius and we multiply it by the cosine of the angle to get the x value, and the sine of the angle get us the y value. And then we draw a line to that new point on the spiral. Okay, so this loops, it generates all the lines. And again, then when we say stroke, it actually draws everything out. I always misspeak and say it draws, but basically it's generating the line. And then when you stroke, it goes back and actually renders it on the canvas. Okay, I think we're good here with this. And spiral doesn't have its own function. All the code is inlined here, which means we should be able to try it. So hopefully I got it right this time, and we'll see if that works. Okay, now normally I use this to test the code, but I actually have two projects open. This one called master where I was copying the code from here and making sure I got everything right. So I want to run this one that I'm working on. So I'm going to go over here and right click and run the file. Now this won't matter for you because you won't have two projects open. You'll only have one and you'll use the green arrow to run it. But I want to make sure that I don't run the wrong file. Okay, this looks pretty good. I have line, rectangle, circle, and polygon. And now from today, I have the spirals. I'll go ahead and select the spiral code. Just to make it interesting, I'll select the fade and I'll hit draw. And sure enough, it doesn't work. Okay, so let me go ahead and stop the video. I'll figure out what's wrong and I'll come right back and work. Well, you know what? I was a silly wizard. You might have guessed actually what happened because now you've done this a few times. I forgot to add the code in to check for the checkbox and add it to the figure set. So even though I had checked it, the JavaScript code didn't look to see if I had checked it. So even though I wanted it to generate some spirals, it wasn't getting the message that it wanted to do that. And because I didn't include any other figures, it didn't do anything. So I thought I had a bug, and actually I just didn't add the code in. So here's the code we used previously for the polygon. I'll just go ahead and copy that. Control C. Come on down here. Control V. And then I just have to change the name of this, and this is spiral check. So spiral check, and we did that at the beginning. So now if it checks and if the spiral is checked, it'll add it to the figure set and then it'll draw it. Okay, let's go ahead again. You know what they say, third time is a charm, and this is only the second. We'll see if we get lucky. All right, here we go. So we'll go ahead and check our spirals. Again, we'll do the fade just for fun and hit, oh, and there we go. So we got some nice spirals happening there. Let's hit it a few more times. And you can see now that we're getting different widths. So this is pretty tight here. I'm still not really, I don't like it when we have a tight one with a lot of space in the center, but it's hard to get it to work really well across all the different sizes. So I think I'm going to be happy with that. Okay, so that's good. We got our spiral done. Let me go ahead and close this and Control S to save. It's already saved. When you run it in NetBeans, it saves automatically. Let's go on back here to our PowerPoint and we'll continue. So from the current slide. Okay, so as I mentioned, originally I had the quadratic and Bezier curves in my master version of the greeting card app. However, I don't really care for the figures they generate. They're not interesting. They're just completely random curves, look like kind of scribbling. And even when you like do a whole bunch of them, it doesn't really look aesthetic at all. So I decided not to include them here in your project because we weren't going to have time to do everything this week. And I'm actually hoping to do some new stuff too that I don't have done yet, which I'm thinking about. We'll see. But anyway, I'll include them in the master copy that you get at the end of the week. So if you want to play with them, you can. Also, I will go over them, and so you can see how we use them. And I'm going to use those two functions in two of the figures that I do, including the one we're going to do here in a moment. So we have these two kinds of curves. They're called quadratic and Bezier. And Bezier is named after a French mathematician that developed it. Quadratic curves are based on quadratic equations. Each curve has one, or in the case of Bezier, two control points. And we define a line segment from the control point to the beginning of the segment the curve is on. And then the curve is constrained to be tangent to these two lines that are formed. And of course, in the Bezier case, the lines are formed slightly differently. So I have some supplemental videos that I've recorded previously on YouTube that you can use for more coverage of this. And I'm going to explain it briefly here, and then we're going to use the quad curve in our cobweb. So here's a really great image that explains how this works. So the quadratic curve has a single control point, and you basically do what you do is you form a line segment, and this is not drawn, of course. It goes from the control point to the beginning and to the end of the curve, and then the midpoint of that segment should be tangent to the curve. So you can kind of see that as this curve moves up, this will get further away. So the way I kind of like to think of it is that originally I have a straight line between the two endpoints, and then as I create the control point and move it away, it pulls the curve, sort of like gravity or magnetism, away. Okay, but that's how it really works. Is it has those tangent points, and of course there's some elaborate mathematics about this, which Wizard Tom is not particularly great at. Okay. Let's see. So again, that looks pretty good. I don't know if you guys have done anything with like Photoshop or like a high-end graphics tool, but in those tools, they have these curves and they actually have a physical control point that you can drag around and shape the curve any which way you like. So that's an example of a quadratic curve. And then the only difference is that the Bezier curve has two control points. And so you can see here are the two control points. Again, we kind of project a segment from the end to the first control point, and the other end to the second, and then a segment between those. And then we generate a segment between the midpoints of those three lines. So that gives me these two segments here. And then those tangent points that I talked about are here, midpoint 2 and midpoint 4. So even though the Bezier curve has an additional control point, it still has only two tangent points. And you can kind of see that this is going to give you a little bit smoother curve than you would get with a single control point. Okay. Now, what I like to use this for is to generate an S shape. So I'll have a shape that'll go like this and then back down around. And so I'm joining this point with this point, and I'll put the control curve here on one side of the line and here on the other. And one of the supplemental videos shows you in detail how to do this. And when we get to our swirl figure that we're going to implement, that uses a Bezier curve in that fashion. And so it sort of creates a random S curve, and then it rotates and draws it many times from a central point. Okay, I got these excellent graphics from a really great free tutorial on HTML5 Canvas programming that's here at this URL. I'll put some sort of resource list together for you that'll have a bunch of listed books and things that you can get, especially web things you can get for free. And I'll see that the people at Ursula get that to you. Okay, so that'll be part of the stuff that you get on the last day. I also have a bunch of about a dozen Canvas programming videos on YouTube. I've been suggesting that you watch some of those. There are some that we probably won't get to that you might want to go in to look further. For instance, you can actually put the text and have it follow a curve and not be just straight text like we're using in the app. So if you're interested in this stuff, you can go further with that. Okay, now let's talk about our cobweb figure, and we'll go ahead and implement it. So this is basically similar to our polygon. So as you recall, when we did the polygon, we used the angle and the cosine and the sine to calculate the points of the vertices, and then we drew the points together to form the perimeter of the polygon, and we used the closed path construct to join the first to the last point. What we're going to do now is we're going to generate the points just like we did before, but now we're going to draw a line from the center of the polygon to the vertex, and we're not going to have straight lines between the vertex. Instead, we're going to draw a quadratic curve, and we'll use the center point as the control point. So they're going to curve inwards towards the center. So the curve will be sort of like the web, and then the straight strands of the web will be the segments that go from the center out. So here's our cobweb code. This won't fit on one slide. I'm just going to show you part of the code, and then we'll type it all in together. But basically, I'll cover the main points. So the first thing that we're going to do is this code is going to draw all the segments from the center to the vertices. So notice we start at 1, and we're going to go to less than num sides. There's some code that's not shown here that sets it up. We move to the center. We also use the translate method like we did in Polygon, so that we've centered the coordinate system now on the center of the figure we're drawing. And so here you can see that I'm calculating Wx and Wy, which are the x and y points of the next vertex. And then I'm going to draw from the center, which I just moved to that vertex. Okay? And then it turns out that I need to remember these points for the next slide. So this is a JavaScript code that pushes the points onto an array or a set, and that set is called points. And notice this is JavaScript notation for an object. So this is actually one object that has an x and a y element, and the value for x is the wx that we just calculated and the wy that we just calculated. So in short, as we get each point, we push it onto this set so we can use it on the next slide. So here on the next slide, now we're going to draw the web between these endpoints, and we'll use the center as the control point. So here we have, we're going to start with the first point, which is in an array. The first point has an index of 0. And then points.length is how many we have, and we want to go one less than that, because if we have 5 points, they're going to be numbered 0, 1, 2, 3, 4. So the number of points of the length is 5, but the last point's value, index, is 4, okay? Now, actually here, I'm going to go even less, so I'm not going to go to the last point. The reason for that is I'm drawing from this point to the next, so point 0 to point 1, etc. And then I have special code that draws from the last point to the first, okay? All right, so we move to the point P, and then and notice this. So this is point P's x and point P's y, and then here's our quadratic curve. We start at the control point 0, 0. We don't start there. That's the control point. So that's constant. They all use the same one. And then from there, we're going to draw to P plus 1, which is the next point, right? So basically, I'm actually using this as the control point, and I'm drawing from point P to point P plus 1, or from this current point to the next one. You could say it that way. And then, of course, each one has an X and a Y. Okay? So that draws all but the last web, and then we draw the last web manually. And you can see that we move to the very first point, and then this is the code points.length minus 1 is really the last point in the array. So this draws from the first to the last point. Again, we still use 0, 0 as our control point. Okay, let's go ahead and code the Cobweb app. And I'm done with the PowerPoint now, so I'll go ahead and close it out. And let's see. All right, so we'll go back into our index.html. We'll work just very methodically like we did before. So we're going to go ahead and copy the spiral stuff in the HTML, and that's the checkbox that the user uses to let us know that we're going to add spirals. And of course, we're going to change that now to Cobweb. So this ID is going to be Cobweb. I wonder if I made that uppercase. Let me check really quick, because I don't want to what I'm doing here in the video be different than my own code. So I just want to check that. Sorry about that. It's best though because otherwise we'll get all out of sync and let's see here. Yep, okay, I left it lowercase. So cobweb, that's kind of like one word and I got confused about that. And then, whoops, I almost made a mistake. So this is cobweb CHK, cobweb checkbox. And then this will be cobweb check as well. Okay, so again, this is the ID of the checkbox, input ID, type equals checkbox, and the name of this is cobweb check. This is the label that goes along with it, and so the 4 connects it with the ID of the other one. The label doesn't need its own ID. So now we'll say cobwebs, and that'll be what the user sees. All right, let's go over to our JavaScript code, go up to the very top. We're going to add the cobweb in, var cobweb, and this is a constant again, like we've been doing. This will equal 7. Again, I've left this, I've left this space in here for the Bezier and the quadratic curve, although we're not going to put those in. I'll just give you those two at the end of the week, okay? But let's keep the numbers there because that keeps my code the same. And now, I'm not sure what's going to happen the rest of this week, but if things go really well and you pick up on this and you're able to, you might add your own figures to our application. And I'm going to try to support that with some supplemental material for you. And so I have some ideas in my head about that. I'm not sure how much of that I'll be able to get done though. And you know, if we just finish what we have, it'll be awesome. But there's always room for awesomer, right? So we'll see what we can do. Maybe I shouldn't say this, but I'm sort of thinking about like we could draw a happy face and maybe some other kinds of symbols. Okay, I just copied the spiral check code. And now I want to make that to cobweb check. So cobweb check. And this, by the way, is the part that has to match the HTML. Okay? There we go. I had the mouse in there. It was throwing me off. So this has to match what I have in the HTML. Now this should be our symbolic constant cobweb. And that's going to add it into the figure. So this is the part I forgot to do on the spiral, and then we had to go back and add it. So hopefully you enjoyed that. My college students always enjoy it when I make mistakes, so they kind of get a kick out of that. And I usually try to leave them in the videos because, hey, you know, that's part of the process. It's important for you to know that it doesn't come super easy, that we all have to make mistakes and work through them and get our code to work. Okay, so case cobweb, and then we'll put our break in. And now I will type the code in because I didn't change it, so I actually have it. And that'll work better to keep up with you. I do have to ruffle my papers here, though, and get to it. So there's the polygon, there's the cobweb. Here we go. Okay. Oops, oh, that's the wrong thing. Okay, so we're going to write a function for cobweb like we did for polygon. So this code, we need to save the context. So g2.save, that saves the graphic context because cobweb is going to translate the coordinate system to be able to write the cobweb. And so we need to save the context and then return outside of that. Now, it looks like I played around with the num sides here to make it work a little bit better. So originally I had all this stuff up in the beginning of the loop, and it would just do it one time. But then as I started to develop more figures, some of them needed to have a little bit different arrangement. So this is going to be math.floor. Whoops, sorry, num sides equals, let me get that up in the center of the screen so you can see it too. So num sides equals math.floor. And then within math.floor, I'll have math.random, parentheses, times, I think we use 10 here, yep, 10. And it looks like we have plus 2. Let's see, is that going to make sense? That's kind of weird, actually, because that means I could have a web that only had 2 strands on it. Here, the number of sides is going to be the strands. Let's just make that a 3 here, just to be on the safe side. Now watch, I'll get killed, so I'll do something that'll mess the code up. So it's always a kind of a risk to change stuff on the fly, but I've got a good feeling that I need to do that. Okay, now we're going to call our cobweb function. So cobweb, and then this takes the context, which is G2. And I didn't show you the whole function, I just showed you the 2 main parts of it there. But you're going to see it in all its glory in a second as we type it in. So we pass the context in, the center point. I modified the radius here, so this is radius times 2. Again, I don't recall why I did that. Probably just I played around with it and it looked better with better values. And then num sides we just calculated. We'll pass that in too. Okay, when we come back, we want to restore the graphics context. So G2 dot restore, and that gets us back where we were at before we went into the method to draw the cobweb. And then a cobweb doesn't have any interior, so we don't use the fill on it. So we use the stroke to render it. And there we go. So stroke, stroke. All right, so now I need to add the cobweb function in that I'm calling here. So I'm not quite done. I need to add a function here just like the polygon, okay? And to make this simple, I'm going to insert it right here before the polygon. So I'm going to start typing that, and this will be kind of long, so I'll try and go slow. So function, cobweb, and then we have our context. It's really quite similar to polygon there. I could almost copy it. And then the radius and the num sides. Okay. And now we're going to create a function body. So we start a curly brace, which is again over the enter key. And I hit return, and NetBeans finishes that for me. And now I'm going to shuffle my papers again and get my cobweb code. And I'll check right sure and make sure that I got it right here with the parameters. So context, XY, radius, num sides. Good, we're good to go. All right. And so we're going to say context begin path, because I'm going to do the translation in that. It'll work better. To be perfectly honest, I'm not sure that we need to do that. And then we'll set the angle. So that's going to be a var, a variable called angle. So we'll set that up. And then we'll set that initially to be math.pi times 2 divided by number of sides. So math.pi times 2, which of course is a circle, a number, oops, missed my equal sign, sorry about that. So var angle equals math.pi times 2, which is the number of radians in the circle, divided by num sides. Again, this is really similar to the polygon code, right? So you can see that I'm doing the same thing that I do for the polygon. And then what's next? We declare wx, wy. So var wx, comma, wy. I'm not going to initialize those because they get initialized as they're used. Again, let me cruise up here so I've got this mainly in the center of the screen. It's a little easier to follow then. Let's see, where are we at here? We need to declare our points array. So var points equals square brackets. So that really just says that points is a set that has many things in it. And we're not saying what they're going to be. It could be numbers. In this case, it's going to actually be an object that has an x and a y value. So that's why I call it points. Okay, time to translate to the center. So context dot translate, and then x, y. That says make x, y, which is the center of the figure, the center of the coordinate system. So that remaps it, so now its coordinates are 0, 0. That just makes a lot of the calculations easier to do. Okay? All right, then we're going to move to the new center. Context dot move to 0, 0. And of course, that's what in the old coordinate system was x, y, and that's now the same thing. So that's the center point of the figure, and it's also the center point of the coordinate system. So now we're going to draw a line, and this will be like we did before with the polygon. So context dot line 2, and then 0, radius. And so again, what this does is the x is 0 and the y is radius. So this is going to draw the first segment due east from the center point, like I explained before when we looked at polygon. And you know, again, you might have had some entertainment there as I kind of flubbed that up. Okay, now we want to remember our points, so we're going to push them on to the points set. And I'll put a little comment in here, add point to set. And so then we say points dot push. And then what I'm going to push is an object. So in JavaScript, I'll put the curly braces in like that. And then the object has two properties, x, and its value is wx, and then a comma, and the second value is y, and its value is wy. So what this does is on the fly, it creates an object which has got two values in it, an x and a y, and the x is set to be equal to the calculated wx. And wait a second, why come I don't have that in there? Let's see. Whoops. Okay, sorry about that. This is going to come a bit later. So let me just go ahead and leave that in and move this down, and we'll get to that in a second. What happened was I read the wrong line of the code. So let me just go back here real quickly. We translate x, y, we move to 0, 0. We do, I see. We draw the line to radius 0, which I did there. Oh, you know what? I made a mistake here too. This one does it differently. Actually, I don't think it matters. But if you think about it now, if I do radius 0, that means the y is 0, and that means it's going to be straight down. So this will be a vertex directly below the current center. So I am going to do push points, and to save time, I'll just copy this line. But that's not what I'm going to put in it. What I'm going to put in it is my first point. And so that's going to be x is radius and y is 0. So we'll just rewrite this here. X is radius and y is 0. So that's the x and the y point. Whoops, I typed y as O. There we go. That's the line that I just drew to, so the first vertex. So before my loop, I go ahead and do the first point and save that into the set. Now I'm going to have a loop to do all the rest. So we'll say for, and then parens, var, and let's do v again because that makes more sense. It's a vertex. And v starts out equal to 1. Sorry, v equals 1, semicolon, and then while v is less than the number of sides, so while v is less than num sides. Again, this is real similar to the polygon code. So basically, this is a loop that goes through the rest of the points on the vectors, starting at point 1, which is the second one. So v++, that means add 1 to v. Now I need to make a body here, go on down, and I'll put the body below that points because I typed that wrong. That's actually inside the loop here, okay? So I'm going to just straighten everything up. And let's see, so we moved back to our first thing. We can just copy that. I have that up here. So I moved to the center point. That code's right there. So I'll just go ahead and copy it. So, and if you'd like, we can put some comments in here. So move back to center. And then now I want to go ahead and calculate Wx and Wy. That's why I noticed I was typing wrong, because I didn't refer to those yet. So I was like, wait a minute, I can't be pushing those into the set if I didn't already know what they are. So Wx equals the radius times math.cosine, which is cos, that's abbreviated, angle times v, okay? And now I'm just going to copy this to do the Wy. So we'll copy it, go to the end, hit enter, control V to paste it back in, run back here, change that to Wy. And then this, of course, is now the sine, not the cosine. Okay? Again, let's look at what's going on here. As v increases each time, we take the angle that we calculated and we add that again. So if I have, say, 6 points, the angle is going to be 1/6 of 2 pi. And then for the second point, it'll be 2 6s, then 3 6s, 4 6s, etc. So that's how it rolls around and goes around the circle, adding the vertices. So then we have to draw a point from the center, which we just moved to. So context dot line 2, and then this is going to be Wx and Wy. And then now we can add the point to the set, and now we're all caught up, and I've gotten back in gear. So I fixed my little mistake there, and we're good. Okay, so what have we done so far? We saw this in the PowerPoint slide. We basically have just drawn all of the lines that go from the center to the vertices. So now we're going to roll back through our set of points and draw the webs between them. So let's put in a little comment about that. Now, draw web between the vertex. We can just say vertices. If I can type, I can say that. There we go. Okay, so I'm going to have this for loop again. And let's see what we did here. I used p this time because it's point. So for point equals 0, while points is less than points.length. So var p equals 0 while p is less than points.length. And then p++. Okay, what does that mean? That means points.length is how many points, whoops, got a typo in there. Points.length is how many points are in the points set. And so the first one is 0, so the last one is 1 minus the length. So p less than points.length will be true until p equals point length, which that's 1 past the number. So the loop will just run through the points that are there, and they're numbered this time from 0 to length minus 1, okay? And the loop will do that. Put the body in for the loop. hit enter to put the closing part in. And now we're going to move to our point and then draw a quadratic curve. You know what? I made a mistake again on this. So what we're doing is we're moving to the current point. Let's put in some comments here. So move to current point, and then draw to the next. Okay, so because of that, I don't want to go through all the points. I want to go through all but the last point because I'm drawing from the first to the second. So if I get on to the last point, I won't be able to draw to the first. I'll have to do that at the end to fix it. So this will draw through all the points but the last web, and then I'll draw that by hand outside of the loop. So again, I kind of missed my code here as I was following it. So the first thing we do is we move to the current points x and y. So that's just going to be context dot move to, and then now this is kind of strange, but basically points is an array, and the index of the particular point is in the variable p. So if you look at this code, p will be 0, that's the first one. And then each one of those elements has an x and a y. So I'm going to do this for the x, and then I can just copy it right over here for the y. Okay? So that says context move to points p dot x and points p dot y. So that moves to the first point, and then we're going to draw to the next. And so I can copy this line to save time. Come on down here and change this from move to line to, which is how we draw. Again, I keep saying draw. It actually creates the line, but it's not drawn until you render it with stroke, which happens outside. Now, if this is point P, the next one is P plus 1. So I'll change the index. And so now I'm going to go to the x and the y of the next point. So there we go. Okay. Oh, wait a second. That doesn't make sense. You know, I don't want to do a line to. I want to do a quadratic curve to. This would end up drawing the polygon again. Okay. So this is actually going to be quadratic curve to. So quadratic curve 2, and then the first parameter is the control point, which is 0, 0. That's one of the reasons that I translated this. And then the rest is fine. Points p plus 1x, points p plus 1y is what we're drawing to. So again, we're drawing a quadratic curve from point P, x and y, to point P plus 1 x and y, and we're using the 0, 0, the center of the figure, as the control point. So that's going to draw all of them except the last, the one between the first and the last. And that one we're just going to draw manually now. And so what we'll do, and you saw this code, I went over it before in the slide, but we're going to just move to the first point. So context move to points square bracket p, that it square bracket 0, the first one, that's a constant, dot x, and then again points. Wow, Tom cannot type. It's late in the day now for me, so I'll be done here in a second, and I'll call this a day and go home and watch TV with my wife. We like to watch our Friday night shows there. So we like the horror shows, Supernatural and Angel and all that stuff. I hope that doesn't turn you off or anything. Some people are kind of funny about stuff like that. Okay, so I moved to the center point. I'm sorry, the first point. I got an extra comment here. Let's take that out. And then I'm going to draw to the last point. And the last point, let's just go ahead and copy this line again. And then it's going to be line 2, which is how we, whoops, it almost did the same problem again. So it should be quadratic curve 2. So quadratic curve 2, 0.0, the first point, let's see, oh, right, I haven't changed that yet. So from the first point, now I want to go to the last point. So the way that I get the last point is that's going to be points dot length minus 1. And then I'll have to put that over here too. So points dot length, that's how many points I have. And so again, if I have 5 points, they're going to be numbered from 0 to 4. So length is 5. Length minus 1 gives me the index of the last one, which is 4. Okay? Wow, that's a lot. I think we are done. Sure enough. Let's give it a test. Here we go. Drum roll, please, is what I say in class when we try code. And so go ahead and run file. Again, you can just use the green arrow to push this. Let's go ahead. There's our cobwebs. We'll select it. We'll hit draw. And it fails again. Let me go ahead and halt the vid, and we'll go ahead. Well, looks like we just had a simple little typo. You probably noticed this when I was typing. I misspelled cobweb. And so later on, when I used it, it didn't recognize it. So let's fix that. And I'm not sure that everything works. I didn't test it. I thought you'd get some amusement out of that, and hopefully it will work. This is my debugger, by the way. I'm going to close that. You don't need to worry about that, but maybe we'll do that some other time. So cobwebs is set. Oh, it's always helpful to reload the page just to make sure you got the right code. All right, here we go. It's still not working. All right, so cobwebs is selected. Draw. Yeah, maybe I'll show you the debugger real quickly. So this is in Chrome. I go to Developer and Toggle Tools. And so you see reference error, ma is not defined. Well, that's clearly a typo. And so let's see if it'll tell us where that is. So let's see here. Oh, so in the cobweb code, I misspelled math. You see it? All right, let's go back into NetBeans. I could fix it here, but that's kind of tricky. So come down here to where I called that. There's the cobweb, and where the hell is it? Oops, that's spiral, sorry. There we go, right there. So math. So like I said, I'm getting tired now, and I made some typos. And I wonder if you caught these while I was typing the code. That'd be kind of cool if you did. All right, let's run it again from here. We should not have to refresh it now. So again, I'll do the fade, I'll do the cobweb. Come on, drum roll, please. Oh, bloody. I was going to say something really nasty. Sorry about that. I'm glad I didn't. All right, developer, toggle tools. And let's see, let's go to our console. Radius is not defined. That's weird. Okay, where is that at? Interesting. Oh, okay. See, we got another misspelling here. You can tell Tom's getting tired here. That's like 3 typos, and they're all just simple misspellings. So let's see, that's in the cobweb code right there. You know, you might not even have these errors if you caught that when I was doing them. So I hope you did. So here we go, run the file. And you know what they say, 5th time's the charm, right? So cobwebs, draw. Oh man, I'm having a bad day now. All right, let's go back to our developer tool. I wonder if we still have a silly error here. And I go to the console. Point is not defined, so that's another typo. God, I got all kinds of typos today. And that's it, line 228. Back to NetBeans. Yeah, see, it should be points. So points.length. Okay. Wow, I sure hope we got it right now. Let's try it. Run the code, run the file. Let's see. Set cobwebs. I like the fade, so I'll set that because it looks cool. Oh, I'm in pain now. This is starting to get silly. So let's see, toggle tools. Wait a second, did I do that more than one time? That's weird. Line 229. Yep, I had that more than once, had the same error. Okay. Let's just kind of scan through it now and see. All right. Fifth time is the charm. Cobwebs, please fade them. Please work. Oh, you're killing me. All right. Go to the console. Type error, not enough arguments to canvas rendering context 2D quadratic curve 2. Okay, so I made a mistake there in the cobweb code for that. That's at line 229. Curve 2. Oh, so points length minus 1x, points length minus 1y. Oh yeah, this has to have the control point. So I forgot to put the control point in there. Okay. Hell, there's nothing left now. So we've worked our way through the entire method. So eighth time is the charm. Here we go. So there's the cobweb. Let's make it fade. Oh, that's pretty. So I like that. And now let's just do a bunch of these. Nice. Seems like it'd be cooler if we had a larger number of segments, but you know what? I'm tired. I'm not going to fiddle anymore today. Okay, so sorry about me flailing around here. We ended up with, no, it's just a little over an hour, so that's not too bad. And I hope you learned something from that. So I didn't really show you a lot of the details of the language programming, kind of letting you pick that up. I have a whole set of JavaScript tutorial videos if you're interested in that. And I did show you a little bit today of how I use the debugger to tell me. So basically, those were all just little typos where I made a mistake typing the code in, and we got everything fixed. So I kind of love those cobwebs. All right, so I hope you've enjoyed day 3 of our great adventure. And I'll see what I can come up with tomorrow for you. And I want to try and set up some optional stuff. If you're really interested and you want to do this on your own, you can add even more to our app. So we'll see if we can get that done too. All right, again, I hope you're enjoying this week, and I hope this gives you a nice taste for doing software development. And maybe I'll see you as a student down the road. So take care. Bye-bye.